Sometimes we're asked to solve an equation that initially looks too difficult, but if we can transform it into a quadratic equation, we can then solve it by factorising or the quadratic formula. These are called disguised quadratic equations and they're part of further maths only. Looking at this equation here, we know that for a quadratic equation and a cubic equation, to solve it we rearrange to equal 0 and then see if we can factorise. So let's start by rearranging to equal 0 in the same way. We can then recognise that x to the power of 4 is actually x squared squared. So let's replace x to the power of 4 in my equation with x squared squared. Now what we can do is we can say I'm going to let x squared equal u. We could use any letter here, but u is quite a common one to use, so we're going to use u. So now substitute x squared equals u, so we end up with u squared minus 4u minus 5 equals 0. And there's a quadratic equation which we can solve by factorising. And we get u equals minus 1 and u equals 5. But we haven't finished. We don't want to know what u is, we want to know what x is. So that means, going back to my original substitution, that x squared is minus 1 or x squared equals 5. Let's start with x squared equals 5. Square rooting both sides gives x is plus or minus root 5. We mustn't forget the plus or minus. With the x squared equals 1, we know we can't square root a negative number. So for this strand, we just write no solutions. I'd like you to pause the video now and have a go at this question here. So this is the solution that you should have got. So just check through and compare yours. This time you'll notice that both strands of our quadratic can actually be square rooted, so we end up with 4 possible solutions. Let's have a look at a slightly different example now. So now we've got an m and a square root of m and a constant on its own. So if we this time let the square root of m equal u, we can rewrite our equation as u squared plus 5u plus 6 equals 0. So if we remember, if u is equal to the square root of m, then u squared will be root m times root m, which is m. So now, like before, we can factorise. U plus 3, so we end up with u is minus 2 or u is minus 3, but again remember that actually means that the square root of m is minus 2 or the square root of m is minus 3. This time to find m we need to square both sides, so we get m is 4 or m is 9. So pause the video now and give this question a try. If you're happy, you can pause and try from here. If you would like a hint, remember that y to the power of a half is the same as root y, so we could write this equation with root y as the middle term, and then you can carry on as we did on the left. So pause now and try this one. So this is the solution you should have got for this question. A slightly different style of question now. So in this question we see that our unknown is the power. We have met equations like this before when we've been doing equations with indices, and in this case we have tried to write the terms with the same base. So that's what we're going to have a go at here. So we can recognise that 4 to the x can be written in base 2 using the brackets index law. So if we just write down here, 4 to the x can be actually written as 2 squared to the power of x, because the 2 squared would give us the 4, and then we're writing it to the power of x. But because I'm multiplying the powers here, that's actually the same as 2 to the x squared. And that's what we're going to use here. So let's go back over to my equation. So my 4 to the x I'm going to write as 2 to the x squared, and that equals 2 to the x plus 56. So now I'm starting to see the beginnings of a quadratic. So I'm going to rearrange to equal 0. Minus 2 to the x minus 56 equals 0. So at this stage, I can do my substitution and I can say, well, let 2 to the x equal u. So I end up with u squared minus u minus 56 equals 0, which is a quadratic that we can factorise. Minus 8 plus 7, so we get u equals 8, or u equals minus 7. But remember, we haven't finished yet. That means 2 to the x equals 8, or 2 to the x equals minus 7. So 2 to the 8 should be fairly straightforward because we know 2 cubed is 8, so that means x is 3. For this one here, actually, if we think about a graph of y equals 2 to the x, so that's an exponential graph from GCSE, that will look like this. So we can see here that 2 to the x must be greater than 0 because there are no y values, negative y values on my graph. So for all values of x, 2 to the x is greater than 0. So in this case, we can't get 2 to the x cannot be negative, so in this strand we have no solutions, and our only solution is x is equal to 3. Right, here's something slightly different, but there are some of these at the end of the exercise, so I'm just going to show you quickly. For a question like this, we can use the idea that 1 to the power of anything is equal to 1. And also we can use the idea that anything to the power of 0 is equal to 1. So if 1 to the power of anything is equal to 1, that means I can put my x plus 4 equal to 1 and solve to give me x equals minus 3. And if anything to the power of 0 is equal to 1, I can put the power in this equation equal to 0 and solve to give me my solutions. And I can do all of this because I have this 1 on the right hand side, and I actually get 3 solutions to this equation. Okay, so if you want to try the challenge questions for this, you can skip ahead and try that now. If you're going to have a go at the super challenge, okay, we're just going to have a look at how we approach or how we start these slightly harder questions. Okay, so we've just got a bit more manipulation to do before we can turn them into a quadratic equation. So this equation we see has got a fraction in it. As with any equation, the first thing we want to do is clear the fractions. So to do that, we're going to multiply every term in the equation by root x. Okay, so in doing that, this is what we're going to get, because remember, root x times x is going to give me x. What we really want to do here is we want to write this in descending powers of x. So we're going to arrange this into descending powers of x. So we're going to start with the highest power of x, which is x to the 1, and then the next power of x, which is root x, or x to the half, and then we've got the constant on its own, and then we should see that we've got a disguised quadratic. So we can carry on as before, let root x equal u, and solve as we've done before. Okay, so that's just one with fractions in. Finally, one with a negative index in. Okay, so the first thing we're going to do here is write the negative index in fraction form. So there we go. To times x to the minus a third would be the same as 2 over x to the third. Then, just like the previous example, we're going to clear the fraction. So we're going to multiply through by x to the third. So what we need to think about here is x to the third times x to the third. Well, remember, that's a law of indices. We've got the same base of x and we're multiplying, so we need to add the powers. So x to the third times x to the third is actually x to the 2/3. So we end up with x to the 2x to the 2/3 plus 5x to the third plus 2 equals 0. And we can see our quadratic here because we've got a squared. So if we let x to the third equal u, then we can form our quadratic to solve. Now this quadratic's got a greater than 1, so you might need to use the grid method, or you might be able to do it by inspection, so that makes that slightly harder as well. So we get u is minus a half, or u is minus 2. So to go back to our substitution of x to the third, we get x to the third is minus a half, or x to the third is minus 2. Remember, x to the third is the same as the cube root of x, so we need to cube both sides. And remember, if we cube a negative, we end up with a negative, so we get x is minus 1/8 or x is minus 8. So these are the questions that I'd like you to do. You can either start on the challenge or the super challenge. The super challenge and the hyper challenge will involve some of those harder ones that we've just had a very quick look at.